Good morning, everyone. I just want to talk a little bit about Module 3, Network Analysis. And in this module, what you're doing is you're looking at then a roadway network and finding out features and characteristics of that. Looking at maybe figuring out the shortest distance from one destination to another, or the closest facility if you have a bunch of different, like say hospitals. Where's the closest hospital to your location, given a roadway network? So it does a lot of things like we already think about, like say, Google Maps or things like that doing, but you see kind of the behind the scenes and how this is done. And so I wanted to look at some of these like typical applications very quickly, because one of the things I want to talk about, as you can see here, like, where's the closest facility? And this will talk about getting that kind of a thing. But I want to talk a little bit about service area, because service area is a really interesting thing that you can do in the network analyst tool. And what it does is, you can see here, these are stations along Chicago's L line. And you can see then these different colored areas are the service areas for that particular station. And by service area, I mean like a walking distance. So these are the areas that you can get like within a certain amount of time walking away from that station. And it increases in time as you see these different colors. Now, the reason I bring this up is because this is something you could do for one of your projects. You could use this, you could create like a service area around, let's say, a public transportation station, and see then, and create that service area within a certain amount of time or a certain distance, and then see who is being served by that station given those conditions. And what you can do too is you can use this as you did the buffer in the previous lab. In lab 2, remember, we were doing a vector interpolation where we used the buffer around the Tempe light rail to figure out the service area. And then, like, because of the way the buffer was, you clipped certain census tracts and census blocks and you recalculated the population. Well, you can do the exact same thing with these kinds of service areas. You can figure out, you can use this to clip to, say, a census tract, and then you can figure out who is being served, the population that's being served in that area, like just first of all the numbers. But when you get into further types of spatial analysis, GIS analysis, what you can also do then is figure out then what are the demographics of these things. And are these demographics that are being served similar or identical or statistically different from the population not being served? And you can see then how equitable the service areas are. I have several students who are doing things related to green space and how the service areas for getting to parks in a particular area are serving a segment of the population, but are they is it an equitable service given their locations? So it can be a very interesting tool and a very helpful tool to use and look at who is being served by a particular thing. Hospitals are also a big thing that you can look at for service areas. Okay, so within this module, go back to module 3. In the module, you can see you have these 2 quizzes, the discussion board, obviously, and then the lab, which is all about network analysis. And you're going to have different parts of this. The first part is obviously generating the network data set. You have to do that because you're going to take then general road file and create the service network based on that. And so this will walk you through it. The second part of the analysis is going to be looking for the closest facility, and this walks you through it again, obviously, and then you'll have a map and questions to answer about that. And then the last part of this is then the shortest path analysis. And again, you'll figure out where's the shortest path for these 2 locations from, the USC to Dodger Stadium. And yeah, you just answer these questions and create the map that's being asked for, okay? Pay attention to how you label things in the map. You want to make sure that you organize all the points on the map and label them what they are, and so that we this 1 and 2 is all great, but like what is 1 and 2? So that should go in either be labeled in the map, or it should be put into the legend so that we have an idea of what those locations are. Okay. Also, that's going to be due on next Monday. In addition to Module 3, you're going to have then a quiz for your final project, and then you're going to have the data sources table here. And in the data sources table, it's pretty self-explanatory. You're just going to put in the data that you think you're using for your project. You'll also have a place to rewrite your question. I'm going to try to get the questions that you turned in done as quickly as possible, so give you some feedback so you can kind of refine that if you need to. And if something comes up where you like, okay, I've completely changed my project, or like I've refined it to this, then it can be slightly different, as long as then the data ends up matching the actual question that you're doing. There's also a list, a section in on that page for the projection, and pay attention to the projection that you're going to use. In some cases, it might be appropriate to use a specific, say, state plane zone, because you're maybe only dealing with a city or a county that falls within the state plane. If you're using an entire state, then you might want to take something like a UTM. Or there might be a better projection if you do some looking around. If you're doing the entire U.S., then you're obviously going to be using something a little bit different, not state plane, something like Lambert-Connick, just because you're doing the entire United States. So you want to pay attention to the projection that you're using, and get the projection that covers the smallest area that your study area fits in. Because remember, the larger area covered, the more distortion you're going to have. So you have much more accuracy with smaller projections. So that's why, in a large portion of the cases, probably state plane is going to be the best. Sorry, this went a lot longer than I thought it was going to. I only want to do a couple of minutes, but I'm close to 7, so I apologize. I will be quiet. If you have questions, you know who to contact. Email me, Logan, talk to the peer mentors, and have a great week.